Hello everyone, I'm Xiao Gang. Let me write down our middle layer here and how this middle layer interacts with our game thread and render thread. Then let's write our variables here first. Well, actually, this part is definitely not written very elegantly because writing it well really tests your skill level. Let me write a temporary one for everyone. Actually, if you have a higher skill level, you can completely remove the lowest level say interface here. And if you want to customize it a bit, you should actually call this interface. Calling these interfaces is also perfectly fine, right? And if you really don't want to deal with it, you just want to say we only have this one temporary requirement, but the lead designer came up with it. We need a dynamic image, this kind of thing. If it is not used elsewhere either, we can just write it like this. Then first, we prepare a UTXRD. And here we need to hold this reference because it is a U class. If you don't have a reference to it, it might be released. So after we include it, we need to directly include our RUTXRD. Then we make a distinction here. We write the engine classes above. This way, we write our own classes in the middle. That makes it easier for us to troubleshoot issues. Contains UTXRD. Of course, you can use a forward declaration here. That's also fine. For example, like this. Forward, declare it like this. Then you need to move this UTextureD to this position. Yes, move it to this position. Okay. At the same time, one thing worth noting regarding this type here, obviously, it's best to do it here. When declaring this delegate here, there is this UText2D. It's best to do it here. Directly make it include this UText2D. Yeah, to avoid the packaging failure issue. Okay, this is just about a header file. It depends on how you want to write it. Then, we need an enum here. Right, very much like our initial state now. We are in this long state. Then we switch this type. We are using this type, right? Back here. Note, let's mark it. We're actually just jumping back and forth between these few files. If everyone follows along step by step, there shouldn't be any issues. Then we have a delegate here. We'll pass this, the WebP. When it's done, we'll have such a delegate. So let's record this delegate. Then we have an index here. That is, it's a loop. Let's check which one our current WebP has been placed on. Then the next one. Okay, to do a loop count. And now we are placed this time. Yes, but it's the calculated time. Okay, then next we will place our image data. These two pieces of image data are the image data we obtained after decoding. Okay, and next is the width and height of this image. Okay, we will hold on to it here. Okay, good, no problem with this. Okay, now let's start writing this. Start writing the load web code. Obviously, first we need to check whether this path is correct. That is, it must be the correct path. Only then do we consider it okay. Here we need to place a pipe here. In this place, it means this white text. We might not be able to see it clearly. It may have failed to analyze here, or for some other reason. Let's try turning it off. Let's restart it. Sometimes when you can't set a bird mode or something, you can turn it off or regenerate it. Because this is an IDR issue, check again. Let's take a look. It seems here. Compile it. Looks like there shouldn't be any problem, but I don't know why this part of it doesn't quite support this. Let's take a look and check. The encoding is also correct. Okay, we regenerated it here. That's it. The combined one. It refreshes and generates the WAS file. Maybe this file wasn't scanned, so it cannot parse it, first, our path must be correct, right? And our current state cannot be this. This cannot be our this state. So it must be in this state. It needs to be acceptable. Static. Why does this place report a static one? Compile it. Check what error this square reports. Try adding a parenthesis here. What it indicates here is, that is to say, this method, maybe this method, and this method, we shouldn't write it as static. Because we don't need to, since this method is obtained through the context of this world. So we don't really need it to be static because our exterior is static. So there's no problem at this point. We can remove this placeholder. So this method should not be static. And then if either of these two things has a problem, then we consider this thing to be invalid. We'll just have it directly execute and say loading failed. We can provide a message. But I haven't written it now, so I'll skip it. Then we proceed with this normal flow, and if there's no problem, we enter this loading phase. In the loading phase, we need to store the information to be used this time. So we need to store this delegate, because we are going to use this proxy later. Right, we need to use this proxy, and then next, we'll just write it like this. It should be fine. We won't write much. We'll copy this pointer. Okay, this is our subsystem. We copy a pointer like this. Then we take this pointer and we call an exec such a straight. Then we give it a lambda. We can use any thread. So here, yeah, right. What data do we need to use? Obviously, we need to pass this path over. After passing the path, we can just capture it directly. Capture this pointer, okay? Actually, there's no need to write this here. Then here, we can just let it execute the decoding operation we wrote in one step and have it decode the data into these variables. These variables are actually the ones on this stack: length, width, height. Right, so these four variables, including the path, capture these four variables. Then we return to the main thread. So basically the decoding is complete. We just need to return this to the main thread. We need to patch and combine this. Then we directly call this load WebP. This is a method that is destroyed. So we haven't written it yet. So let's write this method. This is the method we will use after decoding is complete. This is the method we will use after decoding is complete. We can place this method anywhere, put it under protected. Okay, so this part is done. This part is essentially the decoding being complete. Then let's see what we need to do in our Lodo Wave Pickle show. That is, let's first check if we succeeded. For something like this, whether it succeeded, we usually write the failure case first, because failure is clearer. Okay, so if this fails here, we first restore the state. Then we directly let it execute this agent. We consider it failed. Right, that's it. It seems this one is attached incorrectly. It should be attached to this one. Let's revert the state. Recycle this resource. Okay, then if this one succeeds, if we succeed, we display our state as this. Show in this state. Then we create one here. Picture art. This squared is created like this. Then pay attention to the following code. The syntax differs depending on your engine version. You will see various syntaxes online. My engine version seems to be around 5. For 5.3, the changes between 5.3 and 5.4 should be minor. By creating a temporary UOBJ like this, you see, temporary UOG, these specify some of its format information, format data and such. After specifying them, we need to retrieve its pixel data here, this pointer here, obviously here. In 5.4, he is not allowed to do this anymore. Okay, let's ignore that for now and paste the later part in. Then let's assume we have already arrived here. Then we copy this pixel data in. Obviously, we only need to copy the data from the first frame here. Then we unlock it here. It's clear that we need to use a different method to retrieve it here. Then we let it update this resource. Then we just execute this binding. Okay. Good. We can just use the get method directly for this. That is, we just call this method. But note that originally, we actually directly went directly to click that one. Let me explain this original code to you. Because this involves a knowledge point, it's actually quite important. We originally wrote it like this. Actually, writing it this way in older versions, it was actually the same. But you'll find it doesn't work in 5.4 because it did something bad. It encapsulated this variable for you. Let me point it out for everyone. You can take a look. This is the 5.3 code. You can see. Look at parentheses. You should use this method. Then obviously he left this before. But after the new version, he removed it. Unreal really likes to do things like this. Here you see UXture. Often you'll see UXture and materials. They all have similar situations because he thinks the underlying data structure needs to be wrapped in a layer. This way he can optimize it, optimizing everything that inherits from UTexture 2D. They can all benefit from the optimization. So if you only use one version, then when you use the new version, you'll get such a huge optimization boost. It's like a version benefit. But if you are doing this kind of cross-engine version compatibility work, you will find it very painful. You will find that on average every 2 or 3 major versions, your code will inevitably have 2 or 3 similar kinds of errors. Okay, so here we will give everyone a note. Yes, okay. Here we have left it for you. This is a small tip. That is, when you actually start developing, you will encounter such a problem. Let me explain further. The logic of this segment is what we created. We make our pointer point to this newly created temporary object to prevent it from being destroyed. Then afterwards, what we need to do next is to take the data from our first sheet. Our first sheet of data is this. PLV, color. It has many sheets. We directly put the data from the first sheet into it. Then set our index 0. To record that we are currently on sheet 0. Then finally we let it update. And this update here is actually interacting with the rendering performance because the rendering performance knows it needs to update this data. The data inside this texture can't copy the rendering pipeline into the render after this series of operations is completed. We then let it execute if bound. We take this UTextured, pass this object out, and its length, width, and height are also here. At the very beginning, we copy it out. This length, width, and height are parsed out here. You see, note that this is our to call this underlying interface. Then the underlying interface returns this data to our middle layer. So for this first image, once it's done, it's not finished yet because we still need to refresh this image in the tick. Next, let's refresh this image in our tick. Obviously, this is quite troublesome. We can see that in the tick, we need to do some calculations. First, we must ensure we are in the showing phase. Right, if you are not in this showing phase, then it means you don't need to do this part of the work. At the same time, this texture object must exist. Then we multiply the current time by this factor. Right, because our underlying interface is a hard layer, and this segment is actually a zero-click floating point value. Then we do something like this. This part has a bit of high consumption. We have time to do deeper optimization. Then here we loop through our web timestamp. Such data of ours, that is, it likes our timestamp. Pay attention to this timestamp. It is not, it is this. It is an accumulated timestamp. compared to when we parsed it before. It is quite different, So how do we do it? Actually, it's very simple. If we are currently at 0, we can see that here it is, like this. Let me first show it to you. We need to search based on our current time offset. We need to find which image we want to display. If we are at 0 and our current time is less than this, then it means we remain unchanged. Our web shot index remains unchanged. Let me think about how to explain this part. This part is actually somewhat like the concept of recursion. So let's first look at these two conditions. If your current web index is the 0th one, right? So for our first chapter 0, and this accumulated time is less than the time of chapter 0. For example, if chapter 0 was 16 milliseconds or 32 milliseconds, if it's less than this time, then you only need to display chapter 0 now. Then we find this and currently display chapter 0 if it's the last chapter. Then we reset the accumulated time to 0, and then assign this index, essentially performing such an assignment. Yeah, so essentially you need to display the last chapter now. Yes, display the last chapter. Then this place means that your current accumulated time has exceeded this timestamp. The current timestamp. Then we need to judge the next one. We let it continue. If none of these three conditions are met, we continue the loop. Keep looping until we can exit this loop. That's roughly what it means. I think I didn't explain it clearly. Let me draw a diagram. Wait a moment. Let me draw a diagram. I'm drawing a diagram now. Okay, so actually here, there is such a timestamp. For example, this place is 0123. Wait a moment. Let me adjust this. Okay, let me draw a diagram here. Let me explain it first. This second condition, so if it is the last one, and the accumulated time is greater than the timestamp of our final host, then we consider the last image should be displayed now. Reset the accumulated time to 0. So actually this is what I was thinking. You can see, if our current timestamp is at this position, obviously when we loop through 7, then we keep looping until we reach the host, the last element, when this incorrect time. For example, we consider it to be 70 milliseconds. Actually, we are already at 84 milliseconds here. Then we consider that you should currently be displaying the 7. Then we consider that we have found the image you should currently be displaying is 7. So here we are. We are at this point. Go and clear the accumulated time. Then we set this index to 7 because it is essentially the last one. If it is in the middle, it is easy to understand. Then suppose our current timestamp. We change the color. Change to blue. Our timestamp is at this position. Obviously, during the previous loop process, this time, for example, it is 45 milliseconds, 65 milliseconds, right? Then it will keep going. Keep executing continuously. It just ignores everything before this. It will keep executing until this timestamp. The first time it is greater than our host element, the timestamp inside. So when is the first time it is greater than it? Obviously it is. It is always greater than it. Yes. You can see that is this thing. As long as it is always greater than it, it will continue. It won't go to the part below. It won't go to break. So what this means is when it is 0, 1, 2, 3, 4, it is all less than. But when it is 50, when the main loop reaches the element 50, it is greater than 45 milliseconds. Then it will not execute this exit condition. Then it will go to break. This loop is interrupted at the 50th millisecond. So we quickly find the fifth graph. Then finally we come back to look at the first element. The meaning of this first element is that if it might be equal to 0, and at the very beginning, when it is equal to 0 at the start, then perhaps the first 0 is 8 milliseconds, 5 milliseconds. For example, this is 8 milliseconds. So now we are still at the 5 millisecond stage, right? And we might still be at the 6 millisecond stage. Then we display the 0 image. Right? If we are at 16 milliseconds, then obviously with these in the first image like this, if we are at 45 milliseconds, we display the fourth image. Probably the general idea is like this. For example, at 84 milliseconds, we need to display the 7th image, and then we reset this time to 0, then start again from the 1st millisecond. Such a simple calculation. Okay, cool. So the idea here is roughly like this. Just understand it. This is not the key point. You don't need to worry about this code. How it is implemented, it's just doing a simple calculation like this. Okay, let's look outside. So we find it here. We should currently be determining which image to display. After finding it, obviously on this clothing, we pull it up a bit. We need to modify our texture, so obviously, here, we can just copy it over. Here, we copy the code from above. Here, we need it to get the pointer using the get method. Okay, this way, we have copied the data in, then we simultaneously, because we locked it. So we also need to unlock it, because this thing might need to interact with the render thread. And finally, we let it update. So that's what we need to do in tick. That's it. Okay. Then next, when we release it, we need to reclaim this resource. So when I release it, how do we reclaim it? First, we need to use this switch, because each stage is different. The way we reclaim is also different. We avoid this kind of repeated recycling. If we are in the long phase, we consider that we don't need to do anything. If we are in the loading phase, we only do one thing here. We let it reload. We let it recurse. That is, we may not have finished decoding yet. We need to ensure the decoding is complete. And here, only when we are in the showing phase, do we actually perform the recycling. First, we need to change this state to avoid it looping continuously. Then, we now set this pointer to 0. Then we set our index to 1. Then we also set our time to my. Okay. At this point, we also change the width and height to 0. Then we release the array of timestamps. Then we t away. So we need to release the secondary arrays. Then we release the primary arrays. In this way, we consider all the memory occupied by our entire subsystem to have been cleared. Okay, good. Note that this method we are going to call it when we are destructing. Yes, so here we need to call it. Okay, good. Then we will demonstrate it here. This is our entire middle layer. If it's a bit more complicated, it involves this part. There is something like a video frame. There might be a tricky point here, and this is written a bit too large, so everyone can optimize it. Overall, the middle layer here has been written for you. We'll stop here for this lesson.